Hi, good evening, friends. Today is our last day, so we'll get started. Okay, I'm going to share my screen, but before that, let me open the presentation that we were talking about. Okay, just give me a second. I'm trying to open my presentation. Yes, welcome to the last day of our course. I'm going to share my screen now. Okay. Okay. So yesterday we spoke about machine learning algorithms, right? Or no, we didn't talk about machine learning algorithms. We spoke about what machine learning is, right? We spoke about what machine learning is. We spoke about artificial intelligence, deep learning, uh, and few other things as well, right? So now today, let's focus on into the details. Okay, so if you look at the algorithms itself, okay, there are four main types of algorithms that we discussed, right? Now, what are the different algorithms that are used in different types of learning? We discussed about supervised learning. We said that in supervised learning, it is based on the past data, right? So now, if you look at the objective of supervised learning, could be either to find, okay, continuous target variable or categorical target variables. Okay, let me talk about it. So you see, so we know, okay, we know what is supervised learning, right? We know what is unsupervised. We discussed about reinforcement as well. Reinforcement is based on the learning, right? And semi-supervised is mix of supervised and unsupervised, right? So we have discussed about this. Now coming to the algorithms, okay, there's something called as target variable here. So what do you mean by target variable? Target variable depends upon what you want to predict. Okay, so target variable is what you want to predict. Now, do you want to predict a numerical value or a group value? For example, okay, okay, if you're predicting housing price, what will be the price of the house after 5 years? Let's say you bought a apartment, okay, and you're trying to predict. Let's say you're investing in an apartment. You're investing in an apartment, okay, because you feel that the price of the land, okay, will increase after some time, or the price of the apartment will increase after a few days or few years. right? So on what basis are you going to predict? So you will predict on the basis of, let's say, the location, the nearest hospital, nearest school, etc., etc. Okay, those are called features. Okay, F-T-U-R-E-S, features. Features means the factors based on which you are making prediction. So I just said, right? Distance from railway station, distance from airport, distance from hospital, distance from school, the area. Okay, what is the general price of that area? Okay, what is the trend over last 5 years? Okay, there could be various features. Okay, these are the factors based on which your housing price will depend. This is called target. What do you want to predict? We discussed that in machine learning, we are always trying to forecast, predict. We are looking forward. Okay, we are looking forward. What do we want to predict? What do we want to forecast? Isn't it? Okay. Okay, what do you want to predict? Right now, the housing price, okay, is the value that I want to predict, isn't it? Housing price is the value which I want to predict. So housing price is your target. Target means what you want to predict. Based on what factors? Those are called features. Okay, features would be many. Okay, it can be 1, 2, or 10, right? Or maybe even 50 features. But target, we're talking about one target at a time. I want to predict the housing price or price of the apartment, price of the land, okay, or the sales that we are going to make next month, etc. That's called target. Okay. Now in this, in the target again, okay, if you are trying to predict a numeric value, number, okay, the number is called continuous type. Continuous means what? Number. Why numbers are called continuous? Because your answer can be anything. 1, 1.1, 1.2, 5, 5.9, 5.872, 5.867. Real numbers, isn't it? In mathematics, we call them as real numbers. So your output is not only number, but it can be any number, isn't it? Okay. That's why we call them as continuous target variable. Continuous is numeric. Numeric output. If your goal is to predict numeric output, if your goal is to predict numeric output, then we use regression algorithm. Example, housing price prediction. Housing price prediction is an example. Okay. And since we are trying to predict numeric value, we use regression. So which algorithms to select, algorithms to run? Okay, the algorithm depends upon your end objective. Okay, which algorithm to choose depends upon your end objective. If your end objective is to predict a numeric value, we use regression type. In regression also, we have many algorithms. We're not going to talk about many. We'll just see one today. Okay. Now, next example is called medical imaging. Okay. Now, in medical imaging, you have target value, which is categorical type. Continuous type, number, we use regression. Example, housing price. Now, here, your output is, okay, we are predicting a group value. Categorical means group value. Categorical means group value. Sorry. Okay. Now, let's say you want to predict yes or no, right? Group value doesn't mean that it will have only 2 or 3. It can have 5 or 10 also. But the answer would be one of the given 10 values, not anything like continuous, numeric, not anything like continuous, right? Whether the customer will buy your product or not, yes or no. So if you see in our life, we make only 2 types of decision. how much money to pay, how much to pay, right? How much to pay, correct? And second thing is, should I do or not? Which one should I buy? You have 5 shirts, like you want to go and buy a shirt for yourself. You go to store, you go to shop and you see 5 shirts. Which among these 5 should I buy? Correct? You go to hotel, you want to eat something, okay? You look at the menu, right? Menu might have 5 items or sometimes it might have 50 items. But what you can order is one among those 50. That's called categorical value. Category, okay? So like for gender is a category, male, female. You have education qualification, right? Not gone to school, 10th, undergraduate, postgraduate. These are different groups, different categories, right? So if you are trying to predict, if your intention is to predict categorical value, then we use classification algorithm. Okay. Now here again, the input will be multiple features. Input will be multiple features. Okay. It doesn't matter how many features you have and what kind of features you have. What matters is what is your target variable? What is that you're going to predict? Okay, numeric continuous with you use regression algorithm. This is an algorithm. Okay. If it is categorical value, then you make classification algorithm. Okay, this is called supervised learning, where you have the past data. Okay, you're using it to make your prediction. Great. Now, second type is called unsupervised learning. Unsupervised learning, as we had discussed before, unsupervised learning means you do not have, you don't know, you don't have the output. Okay, so for example, okay, so okay, I'll tell you what I didn't talk about the example here, right? Medical imaging. Okay, so let's say you have this X-ray reports, isn't it? Now, X-ray report, let's say, somebody comes to hospital with complaint of pain in the leg, right? Doctor is predicting, doctor is assuming that there could be a fracture, right? So doctor will ask you to go for X-ray. Now, when you get an X-ray report, you want to predict whether, okay, of course, right now what happens is X-ray report comes to doctor, doctor will look at it and say, okay, fracture is there, okay, or fracture is not there, right? Based on that, treatment happens. But let's say we want to automate it. We want machine to predict if the image has fracture or not, right? So what we have to do is first we have to teach machine, we have to pass lot of X-ray images to the machine to tell them if this is the case, there's a fracture. If this is the thing, it's not a fracture, right? So same thing if you look at, okay, the doctors, when they are doing their MBBS, they will be shown lot of X-ray reports, isn't it, in their college, in their course. They will learn from, okay, X-ray reports which are already there in the college, okay, and once they know how to read it, that's when in the real hospital setup they will be able to predict, right? So here you're trying to predict whether there's a fracture or no. Yes fracture or no fracture, yes or no, right? You're predicting either yes or no in medical imaging, right? So this is an example of your classification algorithm. Okay, so unsupervised learning is where you do not have past data, okay, but you want to predict. Okay, so there are some examples. Okay, there are some examples where it is possible to do that. Here, since you don't have the past data, you won't be able to do continuous values. It is not possible to do continuous value. Okay, now it can be categorical, but we don't know the name of the category. It could be group 1 or group 2. It cannot be yes or no kind of thing. So, okay, so I'll give you an example. Say, let's say there is a room, okay, and the room is filled with 4 fruits: apple, banana, cherry, and mango. Okay, so this is a room is filled with 4 fruits: apple, banana, cherry, and mango. And I ask you to put them all in a bag. Can you do it? Okay, so not in a bag. So now I tell you that I give you 4 bags, okay, and on the backs I have written apple, banana, cherry, and mango. I want you to pick all the apples and put it in the apple bag. Pick all the banana, put it in the banana bag. Cherry in the cherry bag. Mango in the mango bag. Can you do it? Of course you can do it, right? So you will do it. So this is example of, supervised learning, right? So where you've been taught, okay, you've been taught, what is fracture X-ray and what is non-fracture X-ray, and when you take the X-ray, you are putting it in the fracture category or non-fracture category. Unsupervised algorithm is like I give you 4 fruits, okay, but I don't tell you the names and you don't know the names. You have never seen those fruits in your life before. I give you 4 types of fruits, okay, and you don't know, you have never seen, never heard about those and never seen those fruits before. Can you still put them in 4 different buckets? Answer is yes. You can put them in your 4 different buckets. Only difference is you don't know the names of the fruit, but based on the size, shape, color, okay, you'll be able to figure that out, isn't it? You'll be able to figure that out and sorry guys. Okay, you'll be able to figure that out and put that in the bucket. It's called unsupervised learning. Okay, in unsupervised learning, we can still work. Only difference is that the output is not like yes or no, but like a group. Example here is called customer segmentation. Okay, now again, if you log into Amazon kind of application, Amazon is predicting what will you buy, right? So if you log into Amazon, Amazon will tell you people like you have also bought this. Okay, let me see if I can open and show you. Okay, if I can give a demo, let me see. Okay. I'm not able to log in. I think there's some problem there. Okay. So let's say Amazon wants to know, okay, wants to actually, before wanting to know, Amazon wants to make some prediction for you. Okay, we'll tell you people like you have also bought, items. Which items? How does Amazon know people like you? So Amazon will try to look at your buying pattern, right? The characteristic, just like by looking at the shape, size, you'll be able to know, different fruits. Amazon will be able to know based on number of products you buy, which category you buy, how much amount of money you spend, when do you buy. Okay, based on all those factors, Amazon will put it in a group. Let's say if you and I are part of same group, okay, then whatever you buy will be shown to me as recommendation. Whatever I buy will be shown to you as a recommendation, right? So here we both form same group. We both are in same group, right? Now, whether we call this group as A, B, or C doesn't matter. Okay, so there is no label for it. If there is no label, okay, if there is no label, okay, then we use clustering algorithm. Clustering algorithm is when we need to group irrespective of, okay, the input values. Okay, so here you are finding a group and you are saying that, okay, this belongs to this group, right? Customer segmentation, you're segmenting customer. Okay, which customers have similar buying behavior, right? Which customers have similar buying behavior, right? So we use clustering algorithm. Okay. Then we have association. Association is another important algorithm. Okay. So when you go to a retail store, okay, you will see that some products are, any store you go, some products are kept together, okay, in a shelf. Okay. How do they realize, on what basis they put similar product in same shelf? You will see milk and say bread put together. Why? Okay, because what they figured out, when you look at the bill, okay, and let's say if 80% of people who come to you to buy milk also has bought bread. 50% of people who has come to you to buy milk has also bought bread. So what does that mean? It means milk and bread, they're highly associated. They go together, right? They are highly associated. Okay. When they are highly associated, so we put those things together. Let's say you want to, you are buying milk and you forgot to buy bread, you will see bread and you will also pick it up. So it is important. Okay. That's called market basket analysis. What are the items that go together in one basket? And those things, okay. So in retail, every product, okay, where they are placed, how they are placed, which are placed up, which are placed at your eye level, which are placed down, which are placed near counter, which are placed at the end. Okay, so what they will say, okay, onion 2 rupees kg today. They will promote onion 2 rupees kg. You will think, oh, onion is 2 rupees kg. You will go to the shop, and what they will do, they'll put onion at the extreme end last. So when you go to buy onion, on the way you will see other vegetables, other products, you will buy it. Okay. So where they are losing money on onion, but they are making money on other items. Okay. So they're forcing you to come to the store and go to the last so that you pass through all the products. Okay. So this is called association. Okay. And association is an algorithm which finds the association between two products. It takes bill as input, and then it will, it will give you the association. Okay, so it tells us which two products are associated together, which two products are similar to each other. Okay, so these are different types of algorithms. Okay, we can go on and on about these things. Okay, but before we end, see the team, the admin has already pasted the link, okay, where you can find all your videos and content in the chat. Okay, copy that link, save it. Okay, all the videos, the notes, programs we did, and extra additional programs to practice, all those things are mentioned there. Okay, so please save that link and practice. Okay, I always say that programming is like mathematics. Okay, when you see, you'll find it easy, but when you start practicing, you will have challenge. Okay, so please practice first with seeing, then without seeing, and then you can master this. Okay, so please promise me that you will practice all the programs which are there in that link. Please type in the chat, yes, promise that you will practice. If you don't practice, then whole effort will go waste. Okay, so please do practice whatever we are discussing, right? Okay, so these are about machine learning. Okay, I want to do one example. Okay, before I'm sorry guys, I'm not well, I've got bad cold. Okay, so before we end, okay, I want to run a machine learning algorithm for you. Okay, we will use regression. Why do we use regression? Okay, so here you see regression is used for predicting a numeric value. We want to predict a numeric value. Okay, because we want to predict a numeric value, I'll be using regression. So let me look at a data set. Okay, data set which is easy for us to understand. Okay, so let me show you. I have a GitHub location, okay, guys, where I have uploaded all my data set. Okay, so you can actually go to my GitHub and download the data set. You can start using those data set. Okay, no, not data science. We will go to data set. Okay, when you go to data set, these are all different data. Okay, let's say mall customer. Okay, so mall customer. Okay, this is fine. I don't know which one should we take. Not zip, sorry. Look at student. Sorry, guys. So I'm looking for a good data set. Okay, let me look at a good data set. Okay, so this is about another thing. Okay, I want to. Okay, let me go to machine learning. Then that will be better. Let me go to machine learning. Okay, so here we have good number of data set. Okay. Okay, let's look at marks data. Okay, so marks data talks about 2 rows. Okay, we have 31 rows here. Okay, so we have hours and marks. Okay, so hours and marks. Now you tell me, when you look at hours and marks, what would be our y value? What do you think we want to predict? We want to predict marks, isn't it? Because hours, okay, it is in our hand, right? You want to study for 1 hour or 10 hours, it's in your hand. But the marks that you will get is not in our hand, right? So we want to, okay, we want to predict marks, right? We want to predict marks. Okay, so there's a comment here. The teaching was very good. Thank you so much. Okay, thank you so much for your for appreciation. Okay, the next course, the team will let you know, guys. Okay, so we will let you know in advance. Okay, we will let you know in advance about our next course. Okay, thank you so much for your appreciation. You know, it makes me feel happy when you say that, you know, it was good, and I'm happy that I'm able to, you know, make you learn something new, right? So it is always a pleasure. Okay, So yeah, coming back to our data set. So we have hours and marks. As I said here, right? We want to predict marks. I want to predict how much marks my, my cousin or my niece, nephew, or my, family member, relative will get. So that person is in 10th class, right? And you want to predict how much marks that person would get, right, in 10th class. So how do you, okay, first of all, you are predicting marks. Marks is a continuous value, not a categorical value or a group value, isn't it? So we have to use regression here. So this is what we want to predict, marks. And since marks is a number, okay, it can be 1, 2, anything between 1 and 100. Okay, it is your regression type of value, isn't it? It's a regression type of algorithm we have to use. It's a numeric type of value. So target variable here is continuous. Target variable here is continuous, and we need to use regression. Point 1. Point 2 is, what are the factors based on which marks depend? So marks depends, okay, in this case, we have kept it simple for our understanding that, okay, marks depends on only hours. Okay, marks depends on hours. So what you do is you go supervised learning. We need past data, right? It's a supervised learning, so we need past data. So we go to our seniors. So you go to students who have already written 10th exam. So you go for the senior, okay, who have written 10th class exam last year, okay, and you start talking to them and you make a note. So first student said that she studied for 1.1 hour and scored 32% marks. Next, he said he studied for 1.3 hours per week. Let's say this is per week, 1.3 hours per week and scored 37. 1.5 hours per week and scored 30, right? So you end up collecting all this data. So she studied for 10.5 hours in a week and she got 98% marks. Okay. So you populate it. Okay. You create this data set. This data will be the input. Based on this, I'm going to predict, okay, how much my cousin is going to get. Okay. So to read the data from GitHub, we have to go to raw. We discussed this earlier. So let's go to here and I'm going to read it now. Okay, I'm going to read it. Now I'm going to go back to my pie chart. Okay. Move this. Just give me a second. Okay. So to read this file, I need to first import pandas. I'm going to say import pandas as PD. Okay. Now I'm going to read this file. I'm going to say read. So PD pandas dot read CSV. Okay. Okay. And I'm going to read this. I'm going to save this information in a data frame. I'm going to say data df equal to PD dot read CSV. Now data is read. You want to see the output? You can go here and say print data df. Okay. So when you run it, see, same data is read here, right? So I don't know, there's one more column here. We don't need it. We just need one column. Okay. So you want to see this as a scatter plot. Okay. So I'm going to import pyplot, import matplotlib dot pyplot as plt, and I'm going to say plt dot scatter, right? plt dot scatter. Okay. Now your data df, okay, we have to give the column name. So you have to take the exact spelling. Okay, you have to take exact spelling. Okay, now I'm going to say plt dot show. Okay, let's see the graph. See the graph, guys. So based on the data that we have at GitHub, okay, and if you draw a scatter plot, you get something like this. What do you see here? Okay, you will have, you know, on x-axis we have number of hours, and on y-axis we have marks obtained. Okay, now see, to draw a scatter plot, it doesn't matter what you put on x-axis and what you put on y-axis, right? You can put anything and you would get similar graph. But what standard says is, whatever you want to predict, okay, whatever you want to predict, put that on y-axis. Okay, whatever you want to predict, put that on y-axis, and what we know we put on x-axis. Number of hours we study, we know, but marks, how much marks I will get, I will not know, isn't it? So that's why we prefer, okay, marks on y-axis. Generally in mathematics we write y equal to something something, right? So y is what we want to find, so y equal to, okay, and you say, okay, x-axis. So this is your graph, scatter plot. Okay, now we have to make prediction, right? So for prediction we will create what is called as x data and y data. X data could be multiple columns. Here we have only one column, which is your features. X means features. Okay, so let me move on to my pie chart. Okay, so you have features. Features generally we represent as x value. I'm saying x equal to data df, okay, dot ilog. In pandas, this is how we read the subset, right? We read the subset of values. I'm saying all rows, okay, and starting from 0, and we want 0 column only, right? So I'm saying starting from 0 up to 1. 0:1 will give me one value, isn't it? And then I'm going to say dot values. Okay, so this is your features. You can do print x. Okay, I'm going to comment this. We don't want to print this. Okay, so this is our x is red. Okay, this is a feature. Now target variable. Target variable that we already know. So this target variable is what we already know. So here y is going to be, okay, data df dot ilog, okay, all rows, comma, your second column, right? So I'll say 1 dot values. Okay, so this is your y. Okay, so now how to run the regression algorithm, right? So what I'm going to do is, we are going to use sklearn. Okay, now sklearn is called scikit-learn package. We need to install. Okay, you will have to install scikit-learn package. Okay, since I already have it, I don't have to do it. I have to say sklearn dot linear model import linear regression. Now, linear regression is one of the algorithms under regression. Okay, you will have we have multiple algorithms, many algorithms, right? We have linear regression, you know, polynomial regression, you have SVM, decision tree, random forest. Okay, elastic net, raised lasso, then you have neural networks, right? So there are many algorithms. Okay, we are just doing one of the algorithms to, okay, we are making one of the algorithms. We are using one algorithms to show you how regression works. Okay, so when you get into machine learning course, I'm just see the I'm giving you introduction to machine learning so that you know what it is and what we are supposed to do here, right? When you go into this, you'll have to learn many algorithms, right? So this is the most simplest of the algorithm, which is called linear regression. Okay, so we are going to call linear regression. Now we have to create an object of linear regression. So I'm going to say here regressor equal to linear regression. Okay, and now I'm going to say regressor dot fit. This is called model training. Fit is training the model. Okay, teaching. I'm saying model, this is the input, X is the input, and Y is the output, learn from it. Okay, so I'm going to say fit, and then I'm going to say X comma Y. X comma Y. Okay, now when you run it, okay, our model is has learned and it is now ready to predict. Okay, now what is linear regression? Okay, how does it learns the prediction? Okay, how does it learn to predict? Okay, so look here. I'm going to open a paint and I'm going to talk about it. I'm going to run the model so that I take the exact same figure on scatter plot and I'm going to put it here. Okay, see, this is what we got, right? On on x-axis, okay, on x-axis, we have hours, right? On y-axis, we have marks. Now, when I say linear regression, I'm using linear regression model, isn't it? So when I say linear regression, okay, linear regression is trying to find a line, okay, is trying to find a line that will best fit the data. Okay, now this is very similar to what you would have done in your intermediate, second year, first year. Okay, equation of a line. How do we write equation of a line? We say y equal to mx plus c. Isn't it? We say y equal to mx plus c. Okay, this is of course your c, somewhere maybe 25, 26 here. And your m is nothing but change in y, okay, change in y divided by change in x, correct? So in linear regression also, we are trying to find, we are predicting a line which will help us to predict all the values in the graph, which will help us to predict the values from the graph. Okay, now how do we put this line? We have to find the best fit line so that the values are equally on both the sides. Okay, so this linear regression is helping us to find this line, and when you draw this line, you get this equation. Right now, see here we have only one x, hours, but I told you, right, there could be multiple factors. Now say in marks only, one factor could be number of hours you study. Second factor could be number of hours you watch Facebook, number of hours you play, right? Now, more you study, more marks you get. See, it is going in positive direction. So we say that hours is positively impacting the marks. Hours is positively impacting the marks. More you study, more marks you get, directly proportional. Now, if I have to draw marks versus time spent on Facebook. Let's say this is Facebook. Okay, and marks you get. You know, I might get something like this, isn't it? That means less number you spend on Facebook, more marks you get. As you increase the number of time you spend on Facebook, your marks is going to go down. Right? So there could be factors, features. So this is feature 1, this is feature 2. Some feature will have positive impact, some feature will have negative impact. Okay, but okay, and some features will have no impact. In our linear in our linear regression, we take factors which has impact, either positive or negative, doesn't matter. Now let's say if it is Facebook versus marks and hours versus marks, this is positive, this is negative. And let's say I have one more, number of hours you do swimming versus marks. Now, you know, it is like this. Now, if you see, if you draw a line, you get a line parallel to x-axis. Okay, that means number of hours you swim has no impact on marks. If there's no impact, then don't include it. Then you don't include in the analysis. We only include the factors which has impact on the output. Okay, so in this case, this has no impact, so we are not going to put this here. So if you have two features, you will say y equal to m1 x1, okay, plus m2 x2 plus c. If you have n number of features, you'll have m1 x1 plus m2 x2 plus m3 x3, so on up to mn xn plus c. Right? So, okay, so number of factors will of course increase. Okay, so this is your y value. So if we know m1 and you know, slope and constants are constant, isn't it? Now in this case, if you see, if it is positively impacting, okay, you will get a positive m, and in this case you'll get a negative m, right? So it becomes m1 x1 minus m2 x2, right? But in our case, okay, now I'm going back to our example. In our case, we are looking only at 1x, which is positive. Okay, so this is your, okay, now what is the equation? Okay, equation, if you want to print, equation becomes print, okay, linear regression output is m into x, right? How do you find m? We say regressor dot coefficient. Okay, sorry, comma, right? So regressor dot coefficient, okay, this is your coefficient value. Okay, okay, coefficient, and your let me do like this, let me put it in a new line better. Coefficient equal to regressor dot coefficient, okay, and your constant, okay, here I'm going to say slope, coefficient slash slope, okay, constant equal to regressor dot intercept, right? We call that an intercept as well, isn't it? Intercept slash constant. Okay, so it's okay. So see, this is the value. That means, okay, based on this data, okay, we are now predicting the marks. Okay, so I'm going to say y equal to 7.57. This is your slope into x plus 20.7. So if I study for 5 hours, how much marks am I expecting? If I study for 5 hours, then it will be 7.57 into 5. What is 7.57 into 5? 7.57, right? 7.57 into 5 will be what? So it will be around 37.5. 7 into 5, 35, and 0.5 into 5, 2.5, right? So somewhere around 37.8 plus 20.7, right? So you will get, okay, you will get what? 57, 58.5. Somewhere around 58.5 is the marks that you are going to get, right? Now, how do I find it using using algorithm? So we have something called as regressor dot predict. Okay, so when we say regressor dot predict, okay, it will actually predict, okay, how much marks you are going to get. Okay, so you have to pass the values, okay, and based on that, okay, so there is a predict itself, there's a predict function itself. Okay, so there is a predict function itself which will help us to predict. Okay, so let me show you how. I'm going to say output equal to regressor dot predict. Okay, let me give x only. So first we predicted on, we trained on x. Now let's try to predict on x. Okay, so I'm giving x. Okay, and what I'll do is I'm going to create a data frame of actual versus predicted. Actually, how much was the value, and after prediction, how much are we getting? So I'm going to say output df equal to pd dot data frame. Okay, pd dot data frame, and we will create a data frame based on dictionary. Okay, so I'm going to add a dictionary. First header, I'm going to say actual value. Okay, actual, you have x, and then you have predicted output, right? Okay, so hopefully our data frame is created. Now I'm going to print the output data frame. Okay, just 3 lines of code and our regression model is ready. Just 3 lines of code. What is the 3 lines of code? You have create this object, then you fit. Okay, this is where we are training the model, and now we are predicting the model. Okay, we are predicting using the model. Okay, so output actual, predicted. Now when I run output df, you should be able to oops, what is the error here? Okay, so we have to pass sorry, we have to pass like a y value here. Okay, so okay, instead of x, I'm going to say 0 here. Okay, because it's a multi-dimensional, it takes 1 dimension. Okay, so we have to say 0. Now it will give us the result. No, sorry guys, what is the problem here? Line number 25, X should be there. This should run. This should give. It is not giving. Just give me a second. Let me see which line is throwing error. Okay, line number 26. Okay, sorry, 26 is a problem, isn't it? Okay, yeah. Okay, because X is multidimensional, right? So here I have to say Y. Original is Y, not X, correct? My mistake. This is the original value, right? Now we should get it. I'm sorry. Yeah. So Y is the original value that is got predicted, right? Now you get it. So see here. This is the actual value and our model has predicted 29.08. Actual value 37, our model has predicted 30. Now see, our model is doing good job almost, isn't it? Of course, you cannot predict to the accurate, but it is able to predict to a certain accuracy, isn't it? Sorry. So this is how machine learning algorithms work. Okay. If you want to find the error, we have like mean squared error, okay, absolute error. Okay, there are matrices using which we can predict even those. Okay, but I'll stop here. Okay, I wanted to show you how machine learning algorithms work. Okay, and we did one example using linear regression. Okay, so yes, we'll stop here, everyone. I hope you enjoyed this session. I enjoyed being part of this training and interacting with you all. Okay, please practice, and if you have any questions, okay, please put it in the chat. Okay, or afterwards you can put it on the same website, okay, in the comment, and I will answer it. Okay. Okay, is it good? Thank you so much, everyone, and we will see you maybe in future. Okay, but as I said, please practice. Okay, all the best to you. All the best, everyone. Take care. Okay, take care. Enjoy your time. Bye.